First, the poll timeout. The poll duration method in Kafka tells your consumer how long to wait for new messages. Think of it like constantly checking your phone. A short timeout, say 1 to 10 milliseconds, means you're checking almost continuously. You'll see new messages immediately, but it's resource intensive, like constantly checking your battery. A long timeout, perhaps 500 milliseconds or more, means you check occasionally. Messages might pile up, but you save on CPU cycles. For our notification system where instant response is key, we'll aim for extremely short 1 millisecond timeouts. Next, we have fetch size. These settings control how Kafka batches messages before sending them to your consumer. Fetch.minBytes specifies the minimum data Kafka should return, and fetch.max.waitms is the maximum time Kafka waits to gather that minimum data. For low latency, we set fetch.minBytes to 1 byte, meaning don't wait for a batch, just send the message as soon as it's available. And fetch.max.waitms to a tiny 10 milliseconds, ensuring minimal delay if a batch isn't immediately full. Smaller fetches mean lower latency but more frequent network calls. For notifications, speed trumps network overhead. Finally, the processing loop itself. This is the engine that determines how fast you handle each message once it's received. While a single-threaded loop is simple, for high-performance needs, you might consider multi-threaded or, ideally, asynchronous processing. Asynchronous processing prevents slow downstream operations like making an API call to send a push notification from blocking other messages in your consumer loop. This allows your consumer to continue fetching and processing new messages while previous ones are still being delivered. Mastering these three levers is fundamental to achieving high-speed message delivery. Let's put these concepts in the context of Stream Social's architecture. Stream Social's notification system is a high-volume beast, handling over 50 million events per hour. These events originate from various sources: mobile apps sending user interactions, web clients triggering notifications, and back-end services generating alerts.